inverse functions. Already covered few basics in chapter 2 and 6. Removing the brackets and simplifying, performing inverse operations like making x the subject and then replacing, setting up equations to solve problems. Now we are going to just make up simple equations according to the given statement. For example, it says in 22.1, first question, for each statement, make an equation in terms of x, then solve it. A number multiplied by 4 gives 32. So in form of x, a number multiplied by 4 gives 32. And now we solve it. So x is equals to 8. It would start simple and definitely the complexity will increase. B part. In a certain number, if a certain number is multiplied by 12, certain number multiplied by 12 and it gives 96. 96 by 12, x is 8. Try C part.
So n plus 12 equals 55. So 55 minus 12, which would give us 43.
43. The sum of number and 13 is 25.
So n plus 13 equals 25. So 25 minus 13.
N is 12. When 6 is subtracted from a certain number, the result is 14. 6 is subtracted from a certain number,
So n minus 6 equals 14. So n would equal to 20.
20. If a number is subtracted from 9, the result is minus 5. A number is subtracted from minus 5. So n is equals to 14. The result of dividing a number by 7 is 2.5. Dividing a number by 7 is 2.5.
So dividing a number by 7, so 7 has to go first, right?
If resultant of dividing a number by 7, 7 is in denominator.
So n minus 7 equals 2.5.
N divided by.
Oh, dividing. So n over 7 equals 2.5.
Yes.
So yeah, 7 times 2.5, 17.5.
If 28 is divided by a certain number, the result is 4.
So 28 over n equals 4. So that would just be 28 over 4.
And that is
That would be 7.
represent each situation using an equation in terms of y. Solve. Why did we write n? He said x. So we'll replace all the n's with x. Represent each situation using an equation in terms of y. Solve each equation to find the value of y. A number is multiplied by 3, then 5 is added. Number is multiplied by 3, then 5 is added. So y would be equal to y will be equal to 3. 5 goes in the other side, gets subtracted. 14 minus 5 is 9. 9 by 3 is
3.
3. When 6 is subtracted from 5 times a certain number, 5 times a certain number and 6 is subtracted, the result is 54. 54 plus 6
60
by 5, y is 12. C part. 3 times the sum of a number and 4 gives 150. 3 times sum of a number and 4.
So
3
x
times
y plus 4. So 3 brackets y plus 4 equals 150. Yep. And then we divide by 3, and then that gives us 50 equals y plus 4. And then 50 minus 4 y equals 46.
46. D part. When 8 is subtracted from half a number, the result is 27.
So y over 2 minus 8 equals 27. So plus 8.
Yeah. So the
34.
answer is
So it would be 70.
y is 70. Correct. Solve each problem by setting up an equation. When 5 is added to 4 times a certain number, the result is 57. 5 is added to 4 times a certain number, the result is 57. The number is 13. If 6 is subtracted from 3 times a certain number, the result is 21. If 6
1.
is subtracted from 3 times a certain number, the result is 21.
So it would be 9.
So the number is 9. 4 more than a number is divided by 3. 4 more than a number is divided by 3 and then multiplied by 2.
That gives us 4. So x plus 4 equals to 6. So x equals to 10.
Isn't it 2?
X plus 4 over 3 times 2 equals to 4. And then we move the 2 to the other side, which divides it with the 4. So that gives us x plus 4 over 3 equals to 2. And then x plus 4 over 3 equals to 2. And then we move the 3 to the other side, and that gives us x plus 4 equals to 6. So 6 minus 4. So that gives us x equals to 2.
Yeah. A number is doubled and then 6 is added. Number is doubled, then 6 is added. When this is divided by 4, the result is 7.
So 11.
11. Solving more complex problems. The problems in exercise this is so on. We'll just jump to the questions. My mother was 26-year old when I was born. She is presently 3 times as old as I am. What are our present ages? So if I would just say it's daughter or son, whatever. So this is the age of mother and a child. My mother was 26 years old when I was born. So that's 26, and when the child was born was 0. She is presently 3 times as old as I am. So let's say the age of the child is X, age of mother would be 26 plus X. Any doubt? After X
Yes.
years, so X just keeps adding. Now she is presently 3 times as old. So if I would just multiply child with 3, I can say the age is equal, right?
So 26 plus x equals x times 3.
Yes. And
Um,
X comes out to be 13. Now he's asking about present ages. The present ages is 26 plus X and X. So child is 13 years old and mother is 26 plus 13, 39 years old.
so why do we add the 26 with an x?
Because 26 was the past age and 26 plus X is the present age.
Okay. And then x times 3. So that just shows that she is 3 times older than
Yeah.
like her son.
Yes. Yes. So we just multiply to make an equation. When they would be equal, we can equate them and solve them. And definitely this is the other way. Let the present age be X and mother is 3X. So the difference in their age is 2X. And the difference is already known, 26 years old, because when the child was born, mother is already 26. So X comes out to be 13, and we can just plug that back. Find that daughter is 13 and mother is 26 years older. That would be 39.
So they did 3x, which shows the mother's age over the child's, and then minus x, that shows like that shows
Change, change in age.
her getting older. Okay. And that equals to 26 because she is 26 when he was born.
Yes.
And then equals to 2x equals to 26 and x equals 13.
Yep.
Okay.
I personally prefer this method in the right top corner. I'll do that again quickly to compare. Mother and child. Child was born, that's 0, mother is X. After some years, this is their new age. And we know the condition that after some years, she's 3 times as old. So if I would just multiply this with 3, now they are equal. So 26 plus X is equals to 3X. I solve for X and it comes out to be 13. I can plug that back in to find their current ages, which is 26 plus 13, 39, and that was straight away X is 13. So these are their current ages, 39 and 13. A parallelogram has its longest side 5 times longer than the shorter side. If it has a perimeter of 9.6, what are the length of the longer and shorter sides? So perimeter is x plus 5x into 2.
So it would just be 9.6 equals to 12x. So 9.6 divided by 12.
Correct. So 9.6 by 12 is giving value of x is 0.8. So what are the lengths of longer and shorter sides? Shorter side is just 0.8 and longer side is 5 into 0.8. A father is 3 times as old as his daughter. If the father is 31 years older than his daughter, what are their ages? Father is 3 times as old as his daughter. So if the daughter is X, father is 3x. The difference in their age, difference in age is 2x, and the difference is 31, right?
Yes. So
So
2x equals 31?
x is equals to 15.5.
Yes.
Father is 3 times as old. If the father is 31 years older than his daughter, what are their ages? So their ages are x is equals to 15.5 and father is 3 times. 46.5. Jess and Silva have 420 marbles between them. If Jess has 5 times as many marbles as Silva, how many do they have? Jess and Silva have 420 marbles between them. If Jess has 5 times as many marbles, so Silva plus Jess is 420. So x is equals to 70. How many do each have? So first one has 70 and the other has 70 times 5 is 350. So this is Jess, this is Silva. Any doubt? 70 and 350.
I understand 70.
And the
So
other one is 5.
yeah, yeah, subtracted by
Yeah,
420 is 350.
we can subtract 420 and 70, or we could just multiply 70 with 5 because that was 5 times. We had the total, we can subtract also, we can multiply.
Okay.
We'll get the same answer. Number 3. Somik has $5 less than his friend Coffee. If they have 97.50 altogether, how much does each person has? So Somik has 5 less than his friend. So if friend has X, Somik would have X minus 5 and the total would be 97.5. And X comes out to be 49.75. So the first person had 49.75, the other had 44.75. Wait a minute. It didn't add up to 97.5. Somik has $5 less than coffee. So if coffee had X, Somik would have X minus 5. So 97.50 plus 5 divided by 2. That was 51.25. I made a mistake in calculator. This is 51.25. So if first one had 51.25, the other had $5 less. This is 46.25. Yeah.
Yes.
Number 4. Two competition winners are to share a prize of $750. If one winner receives twice as much as other, how much will they each receive? Try this.
So that would be 2x plus x equals 750.
Correct.
250.
So x is equals to 250 and the other one receives.
750 minus 250. So that would be 500.
Correct. Number 5. A grandfather is 6 times as old as his grandson. The grandfather was 45 when his grandson was born. So there's the difference given again. How old is the grandson? I'm getting 9.
So 5x equals 45, and then x equals 9.
Correct. Number 6 is a rectangle of perimeter 74 centimeters, 7 centimeters longer than its width. What is the length on each side? So simply plug in to the perimeters formula. So length is 7 centimeters longer than the width. So if the width is W, length would be W plus 7 times 2 is equals to perimeter. So I'm solving for W. Width is 15. So 15 plus 7 is 22. What are you getting?
I'm about to finish. Wait, I'm confused. So is it not just so if it's 74 centimeters,
Yeah.
then it's 7 centimeters longer than its width.
Yes.
So it's 74 minus 7.
No, no, no. That's perimeter. Let me draw it for you. If the width is 7, the length is 7 more than the width.
Yes.
And perimeter is sum of all four sides. So either we add them individually or we just use the formula that perimeter is equals to 2 times the length plus width. Now the width is just W and length is 7 more than the width. So you solve this equation.
Oh, okay. So it's just 2 divided by 74. And so 2W equals to 30, which is W equals 15.
Yes.
Okay.
So when the width is 15, length is 7 more, giving us 22 centimeters as length and 15 centimeters as width. Smithville is located between Johnsville and Cityville. Smithville is 5 times as far away from Cityville as it is from Johnsville. If the distance between Johnsville and Cityville is 288 kilometers, how far is it from Johnsville to Smith?
So it's 5 times away from Cityville and Jonesville, or 5 times away from Cityville, then 5 times away from Jonesville.
Yes.
So it's separate, right?
Yeah. I'll just write those letters. I'm confused between the names. S is located between J and C, so let this be J and this C.
Yes.
And it is 5 times as far away from C, so it should be somewhere here. So this is 5 times. If this is X, that's 5X. So the total distance is 6X, and distance between J and C is 288. The 288. If
But
you
it
took,
says Smithville is 5 times as far away from Cityville as it is from Jonesville. So is it not like an equal distance?
no, that's 5 times the distance.
So it's only 5 times from one distance?
Yes, 5 times as far from one city than the other city. And the total difference between the two extreme cities is 288.
Oh, so it's going to be 6x equals 288.
Yes.
Okay.
And then it says how far is J and S? So that's 240 kilometers.
So we do 6x equals to 288 and then x. So sorry. So and then afterwards we would subtract it.
Yes.
48 and then
48, 288.
88. So 240. Okay.
Number 8. Amira is twice as old as her cousin. 9 years ago, their combined age was 18. What are their present ages? Amira is twice as old as her cousin Pam. So if Pam is X, Amira is 2X. 9 years ago, so I would say 9 years ago, Amira was 2X minus 9 and Pam was X minus 9. Their combined age was 18. So adding them equals to 18. Does it make sense?
Yes.
So 3x minus 18, 18 plus 18 is 36 by 3. X is equals to 12. What are their present ages? 12
Plus 9.
and 24. Their present ages is 12 and 24. Getting same answers?
Yes. For 8, right?
Yep. Number 9. Jabu left town A to travel to town B at 6 a.m. He drove at an average speed of 80 kilometers an hour at 8:30 a.m. Shifu left town A to travel to town B. He drove at an average speed of 100. At what time will Shifu catch up with Jabu? Okay. Okay. Do you understand the question?
Kind of. So he starts at 6 a.m. and
Yep.
then at 8:30 he is at a speed of 8
They
kilometers per hour. Yep.
Jabu left at 6 and is traveling at 80. And Shifu left at 8:30 and is traveling at 100. The one who left late is traveling faster, so he would definitely catch up at some point. And they need to know that at what time will Shifu catch up. Whatever the time will be, the distance would be equal.
So it has to be
So if Jabu travels, start traveling at 6 and is going at 80 and reached some point, and Shifu starts at 8:30 but travels faster at 100, so he would catch up at this point. So at that point the distance is equal, and we know that distance is equals to speed into time. So distance traveled by Jabu is going to be speed multiplied by time, and distance traveled by Shifu is going to be speed multiplied by time. Would you agree with this equation?
100 t minus 2.5.
Yep.
I understand the 80 times t, but I don't understand the other side.
Okay. Now see, Jabu's been traveling since 6 and Shifu started traveling at 8:30. So he's taking 2.5 hours less to reach the same destination.
Yes.
So that is why I've subtracted it.
Okay.
2.5. So simplifying for t, And T is 250 by 20, 12.5. So he'll catch up after 12.5 hours, and at that time the distance will be 80 into 12.5, 1000 kilometers. I'm giving it a quick check.
So we got 12.5 hours. So it take 12.5 hours for them to like meet at the same point.
Yes.
And then how do we check if we're correct?
By reverse calculation,
So by plugging it in. Okay.
yes. So they'll catch up at 18.5 hours, like 18 hours and 30 minutes.
Then what is 2.5? I mean 12.5.
12.5 is 12.5 hours. They've been traveling since 12.5 hours. So the time on the clock was 6. So after 12.5 hours, it is now 18.6, 18 hours and 30 minutes.
What about for it's the same for Shivu,
Yeah,
Shivu, right?
Shifu took 2.5 hours less. Shifu took 10 hours because he's traveling faster. So if we add 10 and 8:30, that would be 18:30 again.
So 10 and 8:30. So 18:30 is
Yeah.
like at the time they'll catch up.
Jabu is traveling since 12.5 hours. Shifu is traveling since 10 hours.
Mm-hmm.
So if we need to know the time, Shifu would just add 10 hours in 8:30 and get 18:30. And Jabu will add 12.5 hours in 6.
Wait, so Jabu is traveling since 6 o'clock, and then Shifu since 8:30, and then their meet point is 12.5. So we have
12.5 with respect to Jabu, because
okay,
we found out T. T was for Jabu and T minus 2.5 was for Shifu.
yes. So 6 plus 12.5 basically hours.
Yes.
But for um Shifu, that would also be the same? Or is it just the same value for him?
Shifu is 8:30 plus 10. See, Jabu's traveling since 6 and traveling slower. So it took him 12.5 hours to reach somewhere. And Shifu traveled for 10 hours to reach at the same place at the same time because he was traveling faster.
So that would just be minus 2.5.
Yes.
Okay, so we had 10 to Shifu's time.
Yes.
And that gives us the same value, right? 18:30?
Yes. Yes. Now
Okay.
the time destination time is same, the total distance is same.
Okay.
Now if we need to check, we can see that Shifu started traveling at 8:30 and is traveling at a speed of 100 and for 10 hours. So 100 into 10 would be 1000. And do the same, 80 into 12.5 is again 1000.
So it's the same point. Okay.
Cecilia took 40 minutes to complete a journey. She traveled half the distance at a speed of 100 and the other half at 60. How far was her journey? Cecilia took 40 minutes to complete a journey.
So 20
Traveled.
minutes at a speed of 100 kilometers per hour.
No, 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 no. That's time and that is distance.
Oh, so 40 minutes.
40 minutes is in total. We have the speed. So she traveled half the distance. Let me say the total distance was x. So I can say if the total distance is x and we know distance is equal to speed into time, the only known is time. So distance over speed equals time. Let's say for half of the distance, she took half distance is x by 2 over speed 100 and the other half is x by 2 over 60. Now this is time 1 and this is time 2 and the total time is 40.
So it
So
would be x divided by 2 over 100 plus x divided by 2 over 60 equals 40 minutes.
equals 40. Now there's one more twist. This is kilometers per hour. So I'm changing this into hours.
Yep. So 0.66, so 0.7, 0.7. And then can we just make it one? No, we can't because the denominators are not the same. Could we make the
Yeah,
denominators the same?
no issues. We can take the LCM or we can use just the calculator. Cecilia took 40 minutes to complete a journey. She traveled half distance at a speed of 100. So total distance is x and x by 100 half x by 100 total distance over speed is time. So time 1 and time 2. So x by 200 and x by 120. So 1 divided by 200 plus 1 divided by 20. 1 divided by 120 is 1 by 75. That is x by 75 equals to 40 by 60.
Cross multiplication.
Yes. And I'm getting x as 50 kilometers.
Okay.
Now we can quickly check that. Half distance is 25. 25 by 100 plus 25 by 60 is giving me 2 by 3 into 60 is giving me 40 minutes exact.
So we checked it. So the total was 100 kilometers, and then half
Total
was,
was 50 kilometers.
yeah, total was 50, half 25,
Yeah.
and then the times. So we just substituted it again.
Yeah. The question is exactly complete. We're just checking.
Yeah.
See, 25 by 100 should give me time of first half. and time second. And total time should be equal to 40 minutes. So 25 by 100 plus 25 by 60, and whatever the time is into 60 to change it into minutes. See, do we get 40?
Yes.
So the question is correct. Yeah, these are still same statement questions. Okay. Let's do these two worked examples. The product of two consecutive integers is 42. So if the first integer is n, the next is n plus 1. Two consecutive. So product is equals to 42. First number into next number is equals to 42. So we solve for x and we get minus 7 and 6. And we reject minus 7 as the number cannot be negative. So if the first number is 6, the next is 1 more than that. So that's 7. Form a quadratic equation and to find the possible pairs. So 7 and 6. And it could be negative. Okay, no restriction. It's positive, negative both. A rectangle has a length 2 centimeter greater than its width. Same nature question as we did with width and 7 more. So width and 2 centimeters more. So that's W plus 2. The area of the rectangle is 15 centimeters. Find its perimeter. So area is equals to length into breadth one side into second side. And area is given that is 15. That should be centimeters square. Is equal to W square plus 2W. Rearranging W square plus 2W minus 15 is equals to 0. Midterm breaking. I'm trying 5 and 3. W square plus 5W minus 3W minus 15 is equals to 0. So W, this is W plus 5. 5 minus 3 is 2. And then I'm taking out minus 3 is common. So W plus 5 again equals to 0. So W is equals to 3 and W is equals to minus 5. Rejecting the second half and selecting the first one. So if one side is 3, the other is 2 more than that, that is 5. So 3 and 5, and he needs to know the perimeter. Perimeter is equals to length plus breadth into 2. 5, 6, 7, 8, 8, 2 times is 16. So the perimeter is 16. Yes. Any confusion in this?
So we just arrange it in the way the formula is.
Yep.
And then we have to solve it through that one. So 3 plus 5 times 2. And then equals to 16.
Yes.
Okay.
Okay. Now tell me, should I share this exercise or you'll be solving the test for this week?
Today I'll do the test, but you can also share this one.
Okay,
And could you send like a worksheet if you have any on the previous unit as well? Like the ratio and rates?
I'll do it.
Okay.
See you next class. Take care. Okay, we were doing equations, formula, and functions. And we did few of the exercises. Okay, rearranging equations. Using and rearranging formulas, let's just jump to a few examples. Given that c is equals to ax plus b, find x. So we just follow some set rules. When we are looking for x, c is equals to ax plus b. B is being added on this side, so it goes on the other side and gets subtracted. A is being multiplied, so a goes on the other side and gets divided. C minus b over a. Number 7 says, given that m is equals to half x plus y, solve this formula for x. M is equals to 1 by 2 x plus y. Now 2 is being divided on this side, so it gets multiplied on the other side. Is equals to x plus y. And 2my is being added there, it gets subtracted on left hand side. So x is equals to 2m minus y. For example, solve for h. A is equals to 2 pi r into r plus h. So this as whole will get divided. A over 2 by r is equals to r plus h. Then r goes on the other side, 2 pi r minus r is equals to h. Now this is your choice if you want to leave it in this form or take the LCM. So 2 pi r is equals to h. A stays there and it gets multiplied. So 2 pi r square.
So how did we do the LCM?
Okay, doing this step again. This was a is equals to a over 2 pi r minus r. This is basically 1 in the denominator. LCM of 2 pi r and 1 is 2 pi r. This divided by this is 1. 1 into a is a. This divided by 1 is 2 pi r. 2 pi r into r is 2 pi r square. Like we used to do in this case, 1 by 2 plus 1 by 3. So the LCM was 6. 6 divided by 2 is 3. 3 into 1, 3. 6 divided by 3 is 2. 2 into 1, 2. It's 5 by 6. Got it?
Yes.
Make x the subject of the formula. Question 1 is easier than most. So let's see. Question number 1a. M is equals to x plus BP. So BP just goes on the other side and that's x. In question number B, I'm taking x on left hand side and bringing n on a right hand side. So PR minus n. And C part, separating x, 4 goes on the other side and it's divided. Try D part. Meanwhile, I'll just open up some writing space.
X equals square root C plus B over A.
Just there. Question 1 D part. Okay, it was ax square minus b is equal to c. So ax square is equals to c plus b. X square is equals to c plus b over a, squaring both sides, square root both sides. So c plus b over a. Is this what you got?
Yes.
Solving e part. D minus 2b is equal to mx plus c. And I have to make x the subject. So d minus 2b minus c is equals to mx. Now we divide m on this side. D minus 2b minus c over m is equals to x. What would be the answer of f part? You can do it without solving, without writing.
X equals 3b times y.
3b times y, right? X is equals to 3by. G part,
X equals to p over m.
p over m. H part x is equals to n goes multiplied and m goes dividing. I part k multiplies and 2 divides. So mk over 2 is equals to x. J part is again x is equals to 20 by p. Question number 2a. M is equals to 3 into x plus y. So m divided by 3 is equals to x plus y. M divided by 3 minus y is equals to x. I'm going to take LCM again. LCM is 3, so this is m minus 3y is equals to x. This was one way. We could also do this by multiplying 3 inside. This is 3x plus 3y. Now we can do m minus 3y is equals to 3x. And dividing 3 on this side is m minus 3y over 3 is equals to x. So both ways it is same. B part. C is equals to 4 into t minus x. Try this. Let me open the key as well.
C over 4 minus t equals to x.
Use you were doing
Should I
x.
find
B.
the LCM?
So 2b, you're getting this is the answer. Are you getting this?
I just need to find the LCM, I guess.
Okay, go for it.
C minus 4t over 4 equals x. That's the answer, right?
C minus 40 over 4.
Yeah.
Signs are different.
Okay.
40 is positive and C is negative. You are getting positive C and 40 is negative.
Okay,
If
I'll
you are
do
getting minus 4 in denominator, then that's right.
C minus 40. No.
C is equals to 40 minus 4x. C, first thing. Actually, you're making minus x the subject. You have to make x the subject. So if you would have taken this on the other side, you are left with negative 4. So when you divide with negative number, the signs will change. Either you have negative in denominator or you just absorb this negative sign in the numerator. So minus c plus 40 over 4 is equals to x.
And then we can rearrange it to get B,
Yes.
the answer.
Or we could just have done this from this very step. You can take 4x on right hand side and bring c on 4 on left hand side and bring c on right hand side. So you're left with positive coefficient of x. So 40 minus c over 4. And we could also do this when we have c is equals to 40 minus 4x. C minus 40 is equal to minus 4x. Now we already know that we are working for x. So I can multiply the whole equation with minus 1. So this is minus c plus 40 is equals to plus 4x. In order that I get x as positive. So minus c plus 40 over 4 is equals to x. That would be enough. If you wish to rearrange, you can just take the negative number to right hand side and give this as answer.
Okay.
C part. It says y is equals to 3 x minus 15. I've observed that if we multiply the number inside, there are lesser chances to take LCM. So y is equals to 3x minus 15. Y plus 15 is equals to 3x. And y plus 15 by 3 is equals to x. So lesser chances to go for LCM. Try D part.
X equals to 6R minus R over 2R.
So D part is which one did you do?
I did R equals 2R and in brackets 3 minus.
2D. So that's 5 by 2.
Okay, I'll try doing it again. Okay, I see. Yes. 5/2 because I had to cancel out the r's.
Yes. So it just cancels out. I am writing 1 is equals to 2, 3 times 6 minus 2r. So 2r on right to left, making it positive. 6 minus 1. Sorry, that's x. And 2x equals 5 and x is equals to 5 by 2. Question 2e. M is equals to 4c into x minus y. M is equals to 4cx minus 4cy. M plus 4cy is equals to 4cx. M plus 4cy divided by 4c is equals to x. Try F part.
X equals to 2 pi r squared minus a over pi r.
Say that again.
X equals to 2 pi r squared minus a over pi r.
That's right. Okay. First we had a fixed variable which we were making subject. Now every question would just dictate what to make subject. So E is equals to mc square. I have to make m the subject of formula.
A over c squared.
Whereas E equals mc square in terms of m. In terms of r, that's actually already in terms of m. So I'm just making the wording should have been make m the subject. Solve for x, make x the subject. Yeah, like this, make x the subject of formula. So because express E equals mc square in terms of m, that's already in terms of m. But the question actually means to make m the subject. So this is question 3 is equals to m equals E over c squared. Question number 4, I equals p r t over 100. That's formula for simple interest. Just principal times rate times time in terms of r, making r the subject of the formula. So 100 goes on the other side, gets multiplied. That's 100 times I, and P and R are multiplied here, so they go on the other side and divide. P and T. And left with R. Try question number 5.
M equals 2k over v squared.
That's right. Number 6. A is equals to H into A plus B divided by 2. So to make B the subject, so 2A is equals to H into A plus B. Dividing H on the other side, 2A by H is equals to A plus B. And I'm taking A now on the other side, so that's 2A over H minus A is equals to B. Either we leave it here, or if we wish to take the LCM, this will be 2A minus AH is equals to B. Question number 7. V equals AH by 3. This is volume 1 by 3 into area of cross section into height. So making H the subject of formula, 3 goes on the other side, gets multiplied, and then A gets divided. Try question number 8.
I mean 3v over pi r squared equals to h.
Let's check. In real life applications, you will often know the value of the subject of the formula and some of the other values. In these examples, you need to change the subject of formula and substitute. So whatever we've been doing, we'll just rearrange and substitute the value. We can also solve without rearranging them, but definitely fulfilling the requirement of the question. So if V equals LBH, find B when the values are given. So let me write it. Question number 9 gives the formula V equals LBH. One thing is we know that we have to find B. So we can either rearrange it first. And this is what I was saying. If we do not rearrange, we can still solve it because we'll be doing that at a later stage. So volume is 600 divided by length is 34 and height is 26 is equals to B. And if I just substitute these values here, this is 34 into B into 26. So either we do it in the first step, rearrange them, or substitute and then do it. We are ending up with the same answer. And it already says decimal places using calculator, that's 600 over 34 into 26. I'm getting 0.6787. So up till 2 decimal places, this gets rounded. 0.68. Question number 10 says, given that V equals AH, find AH when V is 1.26 and A is 0.41. Do you have your calculator with you?
Yes.
Okay, try question number 10. V equals AH. V is 1.26 and H is A is 0.41.
3.07.
3.07, that's right. Okay, now question number 11 makes more sense because I did 10th without rearranging first. So if we have different values and if we rearrange it once, that will be in a better position. So it says the formula for converting temperatures from Celsius to Fahrenheit says Fahrenheit is equal to 32 plus 9C over 5. Find the temperature in degrees Celsius to the nearest degree when F is equals to 100. Find the temperature in degrees Celsius. So I have to make C the subject because I'll be solving three parts. So it's better we rearrange it once. So F minus 32 is equals to 9C over 5. Now 5 gets multiplied. 5F minus 32 into 5 is 160 is equals to 9C. So 5F minus 160 over 9 is equals to C is equals to C. So now we can substitute values.
52 equals to C.
You've already done it. Okay. 5 into 100 minus 160 over 9. Let me quickly just check it. It's 5 into 100 minus 160 over 9. Yeah, what do you get?
52, but checking from the rearranged formula, I don't think that's correct.
Getting 37.
Yeah. So the
37,
original
38, 100.
formula was F equals 32 plus 9C over 5, right?
Yes.
So I just started with like 100 equals 32 plus 9C over 5. And then I multiplied the 5 with the 100. I don't think I could do that, right? No, I can. And then 500 equals 32 plus 9C. And then I subtracted the 32 from the 500. And I divided it by 9.
Sorry, I missed your voice.
Yeah, so first I just basically like substituted the F for 100 before rearranging the formula.
Okay, you're doing that way. I just preferred it because we'll be substituting three values, so we rearrange it once.
Yeah.
And if you just do that, no issues. This is 100 minus 32 is equals to 9 by 5C. So in your calculator, 100 minus 32 is 68 times 5 is 340 divided by 9 is 37.8 in that order.
Okay, wait. I'll try doing it again, but I'm just gonna.
Yeah, sure, sure.
Yeah. Okay, I see. Okay.
Getting the same answer?
Yep.
Good. Now, because I've rearranged it, I find it easier to just substitute 212 in place of f. 5 into 212 minus 160 and over 9. My calculator actually allows me to punch all the values once. I'm getting exact 100 when I substitute 212. What do you get?
Exact 100.
And what do you get with 32?
5 into 32 instead.
Yes, C part. 5 into f 32. When f is 32, what do you get for C?
5 times 32 minus 160 divided by 9. 0. Wait.
That's right. Because 5 times 32 is 160.
Oh, so it's just 0 over 9.
Right. You can find the area of the circle using the formula area equals pi r square. If pi is equals to 3.14, find the radius of the circle disk of metal with areas. So areas are given. Area is equals to pi r square. I need to find the radius. So area divided by pi is equals to r squared and then square root both sides. So r is equals to a over pi whole square root. And one more thing, that pi to be used is 3.14. So that's square root a over 3.14. Now we just substitute the areas and get the value of r. So for a part, r would be 14 over 3.14 whole square root. And then for b part and then for c part. So what do you get for a?
2.11.
I'm getting same 2.11. B part. Substitute 120 in place of 14.
6.18.
Correct. And 0.5.
0.39. No, 0.4.
0.4. And just to show it up to two decimal places, we'll add that 0.
Okay.
Formula containing squares and square roots. We've done one indirectly in the last one. Area equals pi r square. So make x the subject. If x is already squared, definitely when it is alone, we'll be adding square root. Now you can see that there is plus minus written with square root b over a. I didn't do that when we were solving for area because I knew that area is not a negative quantity, right? When we did this square root both sides, I did not place this plus minus. We didn't do it because the radius cannot be negative.
Yeah.
And when anything is unknown, definitely we'll put a positive negative sign on both sides. See, when we have r, there's no plus minus sign because radius or area is never negative. Given that m is equals to 6 minus 12 over p, make p the subject of the formula. So we could have different approaches. M is equals to 6 minus 12 over p. So this is m minus 6 is equals to minus 12 over p. I'm multiplying the whole equation with negative sign. So minus m plus 6 is equal to 12 over p. Now we can cross multiply. So p is equals to 12 over 6 minus m. Does that make sense?
Yes.
Okay, now look at the answers. I have positive 12 in numerator. He has negative 12 in numerator. That's why we have different signs. Or else it is exactly the same thing. If not understood, I can show it. The worked example says minus 12 over m minus 6. I'm taking out negative as common in denominator. If I do so, this will be minus m plus 6. Now we can cancel out these two negative signs and just rearranging the denominator so they are equal no matter how you write them.
Okay.
Case. Try question number 1. This is 22.5. Just a second. Yeah, number 1.
M over square root m over a equals x.
With the sign of plus minus.
Yep.
Sometimes he's placing that, sometimes he's not. So that won't be an issue in exam as well.
So we can either choose to place it or not.
On safer side, we'll place the sign positive, negative, and when we know what we are finding, we can make the decision.
Okay.
Is like length. Suppose that's temperature, that can be negative. If that's length, that cannot be negative. Try B part.
Square root m plus y.
Square root m plus y is correct.
Plus or minus.
Yeah, that's correct. That's understood basically. C part.
Square root n minus m plus or minus.
M minus n square root is right. D part.
Square root a y plus or minus.
Correct. E part.
AC over b. I don't know. Square root AC over b.
That's right. F part.
Square root a plus b squared.
That's right. If you just speak it the other way around, that's also correct. Like a plus b square whole square root.
Yes.
G part. Sorry, did you say something?
No. I didn't say anything.
Okay. G part.
Square root n over m.
Correct.
Plus or minus.
H part. Now there's root already, and we'll be ending up as squares.
So just x equals m squared y. So x equals m squared y.
This is x is equals to m squared divided by y.
Oh yeah, because it's already multiplied. So m squared over y.
Yeah. I part.
To be a squared over 5 equals to x.
A squared over 5 equals x, right? J part.
Y squared plus z equals to x.
Very good. K part.
Y plus z squared equals to x.
Yeah. If you're just dictating it to someone, y plus z square would look like this. When you say that, y plus z square will look like this. And this, we would actually say y plus z whole square.
Whole squared, okay.
L part. Maybe now we'll need few steps to write.
X equals c over a minus b whole squared.
C over a minus b whole square. That's right. Very good. M part.
M plus a over b whole squared.
Over negative b whole square.
Oh yeah, negative b. Because the negative sign carries.
Yeah. And that would change again because this is a minus b square root x equals m. So minus b square root x is equals to m minus a. I'm dividing with negative b. Square root x is equals to m minus a over negative b. I'm squaring both sides. X is equals to m minus a over negative b whole square. This is enough, but if you want to remove the sign in denominator, this would be a minus m whole square. This is known as equivalent forms.
Okay.
N part is square root 3x minus 1 equals y. So we are squaring both sides. 3x minus 1 equals y square. 3x equals y square plus 1. X is equals to y square plus 1 over 3. O part is a is equals to y minus 2x whole square. Squaring both sides. Y minus 2x. And I'm taking x on left hand side is equals to y minus a square And x is equals to y minus a squared by 2. Try p. Y is equals to a over 4x minus b whole square. Try this.
I think I'm stuck on this part.
Okay, let's do it together. There are two ways, two approaches. Either we bring y on right hand side first, like we switch those while multiplying y into square root 4x minus b is equals to a. 4x minus b is equals to a over y. So cross multiplied, and then we take this for square root, and then we take square on both sides to get rid of square root. So this is 4x minus b is equals to a over y whole square. 4x is equals to, we can also write them separately, which is a square over y square plus b. Now 4 gets divided on the other side. There are different ways we can write here. I'm writing 1 by 4 a square over y square plus b. If you wish to take that inside, we can do that, which will be a square over 4y square plus b over 4. There could be different shapes. So x is equals to, I'm just taking out square as common. I'm writing a over 2y whole square. Do you agree with this shape?
Yep, I agree with the a over 2y squared.
So it could be this, or if I take it on this side, this says a square over 4y square plus b, and we take the LCM. So this is 4y square, a square stays there, plus 4by square. So we can have different shapes.
Yeah, I was
Point
confused
was to
about
make
adding
x the
the.
subject.
Yeah, I was confused about dividing the 4 in afterwards.
How? Okay. Express each of the formulas in terms of A. So he wants us to make A the subject. Yes. Now A and X are at two different places. To A. So X plus A is equals to AX plus B. Now when we want to make A the subject, our first approach should be to bring all the A on one hand side. So I'm writing A minus AX is equals to B minus X. Right? Then I can take out A as common. So I'm left with 1 minus X is equals to B minus X. A is equals to B minus X over 1 minus X. Any doubt?
No.
Whenever we have at different places, we bring them all at one side, and in most of the cases, taking out common is possible. Try B part. L equals BA plus 1 plus CA.
L over B plus L plus C equals to A.
L over, this is P part.
L over B plus L, B plus L plus C.
That's 1 actually.
Oh, it's meant to be a 1? I thought it was an L.
Yeah, that's 1.
Okay, then B plus 1 plus C.
Correct. Try B, C part. After C, go for D. I'll be back in 10 seconds.
Okay.
You're back. Done with B, sorry, C and D.
No, not yet.
Which one are you doing?
I'm still on the C.
Okay.
I'm a little confused with this one.
See, there's no other move other than multiplying on left hand side. First thing. So let me just do it step by step. So if I just multiply it on the other side, that is b into a minus 5 is equals to a. Now I'm multiplying it inside because I want separate terms for a, so I can collect them. ab minus 5b is equals to a. Now I'm taking all the a on one side, ab minus a and all other things on right hand side. Once collected, I can take out a as common. This is b minus 1 is equals 5b. A is equals to 5b over b minus 1. Clear?
Okay. Yep.
Same style for d. Let's do this together. Y is equals to a plus x over a minus x. Now I see a at two different places, so I'm multiplying. This is ya minus xy is equals to a plus x. Now that's a linear equation, straight. Written in a straight line. So we collect a on one side and take all the other terms on right side. So taking out a common, and a is equals to x plus xy over y minus 1. If you wish to take out x as common, you're left with 1 plus y, and denominator is y minus 1. Try e part.
So y minus 3 over 1 minus y equals a.
E part. Is this what you're getting? You're getting y
I'm getting, yeah, y minus 3,
over
y minus 1.
y minus 1. Denominator, if denominator is same, there's a mistake. Either you get
Oh, no.
exactly
Sorry. Y minus 3 over 1 minus y.
over 1 minus y. That's correct. Both of these forms are equal.
Yeah.
Okay. Ma squared equals na squared plus 2. So we just collect them. Ma square minus n square equals 2. A squared is common. M minus n. M minus n is equals to 2. A
Square
square is equals to 2 over m minus n. Now we take square root on both sides. So if we write square root 2 over m minus n, that's fine. If you write this plus minus, that's good. Einstein developed the formula E equals mc square. When he worked on relativity, expressed this formula in terms of C. So making C the subject.
E
E
over m squared equals c.
square root.
Yeah. Square root e over m equals c.
Yeah. Pythagoras theorem can be expressed as this, expressed in terms of A. Make A the subject of the formula. Number 4.
Square root b squared plus c squared. I mean, minus. So square root c squared minus b squared.
Correct. Okay. Given that y is equals to A over A plus 2, so again making A the subject, y is equals to A over A plus 2, cross multiply, ya plus 2y is equals to A, rearrange ya minus A equals 2y, taking out A as common, y minus 1 equals 2y, leaving A behind as 2y over y minus 1. Question 6 is easy, given that the square, that in a square A equals a square, rearrange the formula to find length of one of the sides. So we just take square root. S is equals to square root of A. And this time we will not put any positive negative sign because we are working for length. Okay, number 7. Make y the subject. X over 3 is equals to y by 2 minus 1. So x over 3 plus 1 equals y by 2. And now I multiply 2 on the other side. So I get 2 into x by 3 plus 1 equals y. Either we leave it here or we multiply that 2 inside, 2x over 3 plus 2. That 2 is good, or we take the LCM. So one form, second form, third form, any form. Try 7b.
B minus 2a over 3. So y equals b minus 2a over 3.
Where is this b coming from? You're trying d part, last one. Okay. Okay. BD mixed up. So you tried b. A is equals to b minus 3y over 2. So I just took it on the other side to make that positive. This would be b minus a. So this was 2 by 3 b minus a, right?
Uh,
Which form are you getting?
wait, sorry. B minus 2a over 3.
You should get 2b as well.
So 2b B minus.
Yeah, why are you not getting 2 with B? If you're multiplying this 2 on the other side, that's the wrong step. We either take the LCM first or we rearrange first.
Oh, okay.
CA is
Oh,
equals to B
yeah.
minus 3y by 2.
Yeah.
That would be LCM 2B minus 3y equals A. One thing. Or easy way is that depends on your practice. This was the question. I can multiply the whole equation with 2. So that's 2a equals 2b minus 3y. So in another case, we are getting 2 with b. And y is equals to 2b minus 2a over 3.
So 2B minus 2A over 3.
Yes.
Okay.
B part is simply 3x minus c is equal to y. Try c.
So 4 and then brackets x plus z minus, and close brackets, minus 3z over 3.
Just a second, we'll be there with you. This is 4x plus z is equals to 3y. 4x plus z over 3 is equal to y. What did
When
you get?
um when I was doing it, I took out the 4 from 4x plus 4z equals to 3y plus 3z. I took out the 4 from the 4x plus 4z.
So this was x plus z with you, right?
Yeah,
And on the other side,
it was 3y plus 3z.
so uy plus 3z. Okay. We'll end up with same answers. So you're writing 4x plus z minus 3z.
Yep.
Okay. Now understand one thing. We have z at two different places.
Yes.
And in algebra, that in this case, that's quite possible that we add or subtract them. If they were like x minus z over 2z, this is something else. But they are just being simply added or subtracted, so it's better we open and simplify them. Like we collect the like terms. Remember you doing 3x 7x square plus 2xy minus x square plus 7xy. So what do? We collect the like terms. 6x square
Yeah.
and 9xy. So that's what we're doing. So this is 4x plus 4z minus 3z is equal to 3y. So we just collect them.
So 4x plus z over 3.
Yes, is equals to y. Applying your skills in physics, the kinetic energy of the particle can be found by formula E equals half mv square, where m is the mass and v is the velocity of the particle. Find E when m is 8 and v is 3.5. So this is 0.5 into m to 8 into 3.5 square. I'm getting 49.
Me too.
Show how you could rearrange the formula to find V.
So 2e equals, no, 2e over m equals v squared. So square root 2e over m equals v.
Yes. Correct. Number 9. The volume V of the cylinder is found using the formula V is equals to pi r square h, where r is the radius and height h is the height of the cylinder. Find the volume correct to the nearest centimeter cube of the cylinder when the radius is zero point 0.8 and height is 1. So I'm substituting in calculator, that's pi into zero point 0.8 square and height is 1. Correct to nearest centimeter cube, I'm getting 2. What are you getting?
Oh wait, let me do it too, because I was just going off what you were saying. So 2.0096, so technically just 2. And then we
Yeah,
rearrange to
to
make r.
nearest. Like we won't be using the decimals.
Yeah.
Okay, we left it here. Number 10 says you can use the formula A is equals to pi d square by 4 to find the area of the circle where d is the diameter of the circle. Find the area of the circle when diameter is 1.2. So we just substitute pi d is 1.2 squared by 4. I'm using calculator. And it gives me 1.13 up to 2 decimal places. Use the formula A equals pi r square to find the area of the same circle. So this is pi and radius will be half of 1.2. That's 0.6. Pi into 0.6 squared gives the exact same answer, 1.13 meter square. Express the formula A equals pi d square by 4 in a way that would allow you to find the diameter of the circle. So we're making d the subscript of the formula. 4 goes on the other way, multiplies with area, pi d square. Then we divide pi on the other side as 4a over pi equals t squared, taking square root. T is equals to square root 4a over pi. You can leave this as it is or bring 4 outside. So that's 2 square root a over pi. Next subtopic is functions and function notation. A function is a rule or set of instructions for changing one number, the input, into another, the output. If y is the function of x, then the value of y depends on the values you use for x. In a function, there are only one possible value of y for each value of x. Function notation is a mathematical way of writing equations. Functional notation is widely used in computer applications and also in technical fields. Think about the equation y equals x plus 2. Now let's take that example, y is equals to x plus 2. Now we just said that if y is a function, so x is the input value. So for example, I take x is equals to 1. So when we substitute x1, I'm getting y as 3. So I'm writing x1 would give y equals to 3. Let me say these were x and these were y. So when x is 1, it is giving me y as 3. So when I change the value, let's say x as 7. So it gives me y as 9. So 7 gives me 9. For every different value of x, I'll get a value of y. So that is function. This is linear function at the time. We'll talk about this more when we touch the quadratic function. So functions can also be written as this. This very function could be written as f is such that it is a function of x, which is x plus 2. When there are two or more functions involved in a problem, use different letters representing them. For example, so you could have g of x. So anything like, for example, f of x is equals to x plus 2, and then there's another. So I may write g of x is equals to x square plus 4, and if there's another, fgh of x is 2x square minus 7. So if you have different functions, we'll be using different letters to represent them. Okay. The steps taken to work out the value of any function can be shown on a simple diagram. So this is just simple substitution. If I am representing this, adding any number, so we can just substitute and solve. Given that f of x is equals to x square minus 3x and g of x is equals to this, so find the values of. So when the examiner tells you that x is 6, because this was f of x and he's writing f of 6, so basically he's replacing x with 6. So if f of x was x square minus 3x, now we replace x with 6. The 6 square is 36, 36 minus 18, I'm getting 18. Same way, of minus 3, we substitute minus 3 in place of x and we get 18 again. Now, one thing you need to know that for different values of x, we may have same value of y. One such example is this curve. For example, at this value of x, I am getting one value y. Another value of x, I'm getting another value y. Different x, different value of y. For every x, you'll get a different value. But for one value of y, we may get it from two different values of x. For example, let's say I draw a horizontal line and let me call that this is y is equals to 4. So y equals to 4 is possible for these two values of x. Just like we did now, that at 6 I'm getting 18 and at minus 3 I'm getting 18. If I would sketch that, Let's say this is x6 and this is x minus 3. So at x6 I'm getting 18, at x3 I'm getting 18. So if I would sketch it, it would look like this. At x minus 3 y is 18, and at plus 6 y is 18 again. So simply find the values of g of 1 by 2, we just substitute 1 by 2 here, and then g of 6 we substitute here. Whichever function is linear, you will not encounter any same values, because that's just a straight line with increasing value of x, value of y is increasing. It may have a negative gradient with increasing value of x, value of y is decreasing, but due to being linear, there's no repetition. Given that h of x is equals to 9 minus x square, write down the expression for h of x. So first of all, h of x is equal to 9 minus x square. We're just changing this into this expression. Now find h of 0. So when you replace 0, that is 9 minus 0 square, you just get 9. When we replace 3, so 9 minus 3 square is 9, 9 minus 9 is 0. You replace 9. So 9 into 9 is 81. 9 minus 81 is negative 72. Then we have minus 9. So 9 minus minus 9 squared. This is 9 minus 81. This is minus 72. So at plus 9 and minus 9, we're getting same values. Worked example 14. It says f of x is equals to 3x plus 2. F of x is equals to 3x plus 2. Then it says f of x is equal to 6. So I'm replacing this complete left hand side with 6. And when this is 6, what is the value of x? So we can make x the subject. 6 minus 2 equals 3x. Just got stuck. Let me reopen it. So this is 4 is equals to 3x and x is equals to 4 by 3. At x 4 by 3, f of x is 6. My bad. I copied 3x plus 2. This was 3 plus 2x. F of x is equals to 3 plus 2x. So 6 is equals to 3 plus 2x. 6 minus 3 is 3 is equal to 2x, and x is equals to 1.5. Given the functions f of x is equals to x square and g of x is equals to x plus 2. That's quadratic, that's linear. Solve the equation f of x equals g of x. Simple substitution. So we replace f of x, which was x square. Then we replace g of x, which is x plus 2. Now rearranging, this is x square minus x minus 2 is equals to 0. This is your choice. You go for midterm breaking or completing square or quadratic formula, anything. So I'm using midterm breaking. So if I multiply minus 2x with plus 1, I get minus 2x square. And when I add them, I get minus 1. So taking out x common, this is x minus 2 plus 1 common. X minus 2 is equals to 0. I have these two brackets same. So x plus 1 into x minus 2 is equals to 0. So first possible value of x is minus 1. And the next possible value is x is equals to plus 2. Second part says solve the equation 4 times g of x equals g of x minus 3. Again, simple substitution. This is 4. G of x is x plus 2. is equals to g of x, which is x plus 2 minus 3. So that's 4x plus 8 minus x minus 2, or I'll just keep this to right hand side, is equal to 2 minus 3 minus 1. So 4 minus 1 is 3x. 8 goes on the other side, negative 8, and negative 1 is negative 9. So x is equals to minus 3. Any confusion till now?
No.
For each of the function, calculate f of 2 minus 2.5 and 0. Let's just select few values. Okay. I'm selecting one linear and we'll do with one quadratic. This is exercise 22.6. So question number 1a, f of x is equals to 3x plus 2. So we're looking for f of 2. That's 3 into 2 plus 2. 3 2 is 6 plus 2 is 8. Then we are doing f of minus 2. So 3 into minus 2 plus 2 is minus 6 plus 2. That's minus 4. Then we're looking at 0.5. F of 0.5 is equals to 3 into 0.5 plus 2 is 1.5 plus 2. This is 3.5. And the last value is f of 0. F of 0 is equals to 3 into 0 plus 2. So 0 plus 2, that's 2. Let's see f part. Let's cube. F part says f of x is equals to x cube minus 2. F of 2 is 2 cube minus 2. 2 cube is 8. 8 minus 2 is 6. F of minus 2. Minus 2 cube minus 2. Minus 2 cube is minus 8. Minus 2, we get minus 10. Then we have f of 0.5. This is 0.5 cube minus 2. If it would have been 5 cube, that is 125 over 1000. So 0.125 minus 2. 0.5 into 0.5 into 0.5 is 1 by 8, which is 0.125 minus 2 is negative 1.875. Negative 1.875. And the last one was for f of 0. So that's 0 cube minus 2, and I get minus 2. Okay, for each of the function, find f of x equals this. These are simple substitutions. Mm, Try question number 2, C part.
F equals to 5.
Correct. F of x equals to 5.
Yeah.
Or we should say f of 1.5 equals to 5.
F of 1.5 equals to 5.
Try 3C.
F of x equals to 5.
Yes. Given that the function f of x equals x cube minus 8, g of x is equals to 3 minus x, find the value of try b part and then c.
B is f of -1 equals -9.
Correct. And f of 5, g of 5,
-2.
-2. Try question number 6. That's a twisted statement. Let me write that. I'll solve that with you. Question 6. It says f of x is equals to 3x minus 1. And then it says f of x is equal to 3 f of x. How could that be? Is equals to 3. Find x. I think this thing is a glitch. F of x should be equal to 3 and 3x minus 1 equals 3. 3x is equals to 4. X is equals to 4 by 3. Let me check the answer. This was 22.6. Question 6. 22.6. Question 6, 4 by 3. There it is. At the top. That is just typo. This is typing error. This can't be. Any doubt?
So we just no. So we just find it. Well, just it equals to 3. So we just
Yeah,
find x. Okay.
we just find x. Same scenario, question number 7. Try this one. H of x is equals to 1 over x plus 1. And it's given that h of x is equals to 4.
X equals to 1.
I didn't mention getting something different. If that's 4, 1 over x plus 1. So when 1 goes on the other side, 3 equals 1 over x. So we can go for cross multiplication or just reciprocal on both sides. 1 over 3 equals x. It's not 1, it's 1 by 3.
Oh wait, we're supposed to find. Oh yeah. Okay. So we just did like the reciprocal, right?
Yes.
Okay.
Question number 8. G of x is equals to square root 4x plus 1, and g of x is given that's equal to 5. So we find the value of x.
X equals 6.
Correct. X is equals to 6. Number 9. Given the function f of x is equals to x square minus x, f of x is equals to x square minus x, and g of x is equals to x square minus 3x minus 12. So it says solve the equation f of x equals 6. So f of x equals 6. We replace f of x with the given function and solve for it. So x square minus 6 is equals to 0. And this should be 3 and 2 minus 3x plus 2x minus x equals 0. So x is x minus 3, and then plus 2, x minus 3. So x plus 2 into x minus 3. First factor equals to 0, second factor equals to 0, and we're left with x is equals to minus 2 and x is equals to 3. Okay, we are getting these values in some questions. We would have restrictions such as the examiner would say that the value of x is positive or x is greater than 1 or something. So definitely we're going to reject the other values.
Okay.
And in the second part, it says f of x is equals to g of x. Simple substitution again. F of x is x square minus x, where g of x is x square minus 3x minus 12. So we get rid of this x square, bring that to left hand side is 3x minus x plus 12 is equals to 0. It's 2x equals minus 12, x equals minus 12 by 2, and x is equals to minus 6. The question is complete. During exam, if you wish to check, you can always do that. This is minus 6 when f of x and g of x are equal. I'm substituting minus 6 in this. So that makes it 36 minus minus plus 6. That makes it 42. And then trying the same number here, 6 square is 36. And minus 6 into minus 3 is 18. And then we subtract 12. I'm getting 42 again. That was just a cross check, not required. Okay. Question number 10. Do you know what you have to do in this question?
So we would just substitute the a into the 2x.
That's right. So this is just 2a. B part is f of a plus 2. So we substitute this whole in place of x. Either we leave here or just write 2a plus 4. This is actually, we have to be careful when this is quadratic because sometimes students forget to open this a plus b whole square. They just do a square plus b square and forget this plus 2ab. A minus b whole square is a square plus b square minus 2ab. And a plus b into a minus b is a square minus b square. So f of 4a is equals to 2 into 4a gives you 8a, and d part is 4 times f of a. So that is 4 times f of a is 2 into a. That's 8. Okay. So this condition would always be given. That's just for the convenience that x, the denominator can actually not be 0. So f of x is equals to 4 plus x over x. Calculate simple substitution and then we find the value of x. Question number 11. F of x is equals to 4 plus x over x. So it says f of 1 by 2 is equals to 4 plus 1 by 2 over 1 by 2. So that's 4.5 over 0.5 is 9. Try B part. F of x equals 3 and f of x was 4 plus x over x is equals to 3. Simplifies to what?
X equals to 2.
Correct. Question number 12. F of x is equals to 2x plus 1 times x plus 1. This is quadratic, but the requirement is simple substitution. So f of 2. Are you getting this?
Yes.
Done?
Yep, done.
Okay. Okay, now next comes in composite function. A composite function is a function of function. You get composite functions when you apply one function to a number and then apply another function to the result. Like you're actually substituting, first we were substituting a value of x in another function. Then whatever we get, we will substitute this in another function. This could be different. This could be same. We substituted this in f of x and then whatever we get, we substitute back in f of x. So substituting one function in another or same. One of the example is this f is substituted in g and this is f is substituted back in f. We'll do it step by step. So for example, f of x is given, g of x is given, and it is asking you for f of 4. So at f of 4, you actually get 9. And then you're substituting this 9 in g of x. So actually, if I would not substitute and just write the question, this would look like this. G, f, x. We read it from right to left. We say that x is substituted in f, and then we can say that f is substituted in g. If I would use brackets, this would look like this. X is substituted in f, and then f of x is substituted in g. We don't do that In algebraic form, that complicates it. For example, f of x is 2x plus 1. If I would just substitute it here, this would look like this: g of f of x. So I'm replacing all the x with f of x, and then I can replace f of x, which is 2x plus 1 whole square. So that expands a lot: 4x square plus 1 plus 4x. And definitely I'm going to get the same value again. We used 4 in place of x. So this was 4 into 4 square plus 1 plus 4 into 4. So 4 4 is 16, 16 4 is 64 plus 1 plus 16. So 64 plus 1 plus 16 is giving me 81. Getting the point? This is 81, this is 81. No matter how we do, this is math, we end up with same answer.
Yep.
So it's easier handling the numbers. So we substitute 4 in f first, we get a new number, then we substitute that number in g of x. Like in these cases, if he says gf4, so I'll just check what is f4. So f of 4 is 4 square minus 2 into 4. I'm getting 8. So I would substitute that 8 in g of x. So that's 3 minus 8 and minus 5. That would be smooth.
It can't be backwards, right? Like it can't be g of x substituted into f of x. That would be too long,
No,
right?
it has to be this way. We cannot change the order. We read them from right to left. GF4 means you substitute 4 in F, then whatever you get, you substitute that in G. Because
Okay.
GFX is not equal to FGX, or it may be equal at a very specific value, but they're
Okay.
not always equal for all values.
Okay.
So we need to be in that order. So second one, yeah, it's right there. See, GF4 and FG4 are different answers. So when we do G of 4, that is 3 minus 4, that's minus 1. So we substitute minus 1 in f of x. Minus 1 square is 1. And minus 2 into minus 1 is plus 2. So plus 2 plus 1 is plus 3. Now ff minus 1 is f of minus 1 first. F of minus 1 is equal to minus 1 squared minus 2 into minus 1. So that's 1 plus 2, that's 3. Now f of minus 1 is 3. And this second f says substitute this back. Now we substitute 3 in that. So I'm getting 3 squared minus 2 into 3 is 9 minus 6 is 3. Getting it? I'm just cutting it off and try B
Yeah.
part.
Okay. That would be 100, right?
That's right. Okay. For each pair of function, evaluate this and then this. Okay, now the examiner is actually forcing us to handle algebraic forms. As I said earlier, that when there will be numbers present, we'll definitely go for numbers. Okay, this is 22.7, question 1. F of x is equals to x plus 6. G of x is equals to x minus 3. And I'm solving for fgx and then gfx. So first of all, g of x is being substituted in f of x, and that's f of x. So in place of x, I'll write g of x plus 6, and g of x is x minus 3 plus 6, and that would be x minus 3 plus 6 and x plus 3. Now I did show all and every step. On right hand side, I would try to do it direct. I have to substitute f of x in g. So I'm writing it direct in place of x, where f of x is x plus 6 minus 3. So that's x plus 3 finally. This is a coincidence that we are getting the same value. That won't be the case every time. Let's try this b part. So f g x. So I'm getting this g of x and substituting in f2 bracket. Wherever x is, we replace it with g of x squared minus 3 another x. So we replace with g of x plus 1. Can you see the substitution? I'm talking from right hand side.
Yep.
Okay, now simplifying. So this is 2 into 5 times is 25x squared minus 15x plus 1. So that's 50x squared minus 15x plus 1. Solving in parallel, what is the comparison? G f of x. I'm looking at g of x. There's only one substitution and writing the complete function. That's 2x squared minus 3x plus 1. So 5 2 times is 10x squared. 5 3 is a 15 minus 15x plus 5. You see, in the first case, they came out to be equal. They were linear functions. These are quadratic. We end up with different functions. Try, which one would you try? C or D? Select any.
D.
Okay. D. Try it, then I'll display the answer. Is it readable?
Yep. Okay. So f of gx.
I'll display and we'll compare. This is
Oh, okay.
22.71D. 22.71D. Yeah. Are you getting this?
Yeah, I am.
And second part done or you're doing it?
No, I did both.
Okay. Both second one is this at the top.
Yeah. I checked both. Both are correct.
Okay, nice. Okay, question number 2 says f of x is equals to 2x and g of x is equals to minus x. So find this. If I'm looking at a part, that's again algebra variables, and b part will be numerical answer. So f of x equals to 2 and g of x is equals to minus x. So in a part, question 2a, I'm just substituting g of x in f of x. So g of x is minus x, f of x minus x. So this is minus 2x. B part. Now B part says fg2. Luckily, I've already done fg. So I can just substitute fg2. This is fg already. So I can just substitute 2 in this. If this was not done initially, I know that I have to substitute 2 in g. I would just copy this. G2 is equals to minus 2. Now that's minus 2. Now I'll copy this minus 2 in f. And f was equals to 2x. So 2 is minus 2 and minus 4. F4. F of x is equals to 2x. And examiner is asking for F4. So if I substitute F4, this gives me 8. Now I'm going to substitute 8 back in F. So that's f of 8 is 2 into 8 is 16. D part is GF1. GF1. And there is the function. So I just substitute 1 in f of x. So that's g of 2. And then I substitute 2 in g of x. That's minus 2. Any doubt?
No.
Okay. F of x is equals to 3x plus 1 and h of x is equals to 6x square, linear and quadratic. Question 3, A part. F f x. So we just substitute f in f. So that's 3. This is the bracket. This is 3x plus 1 as whole plus 1. F substituted in f is 3. 3 times 9x plus 3 plus 1 is 9x plus 4. E part says f h x. So we substitute h of x in f of x. So while writing f of x, we replace all the x's with h of x. 18x square plus 1. Try C part. H minus 2.
3,456.
3456 is right. Try D part. H minus 2.
150.
Let me solve. Or let me just check. This is 3D is 150, right? Hmm. Question number 4 seems pretty much same. One quadratic, one linear. And let's just try. These are all number, no variables. Try question number 5. I'll do this with you. I'm
Okay.
done.
Yeah, me
Yeah.
too. So for g of h4, I got 5. And then h of g4, I got 1.25.
First one 5 and second one
1.25.
1.25. I think you forgot to take the reciprocal. G of 4 is 1 by 4, right?
Yep.
And then we substitute 1 by 4 in x.
Yes. Okay. Plus 1 over 1. It's just 5 by 4, but then
No, that's 5.
1.25.
That's 5 by 4 in the denominator. See this? This is h of x is equals to 1 over x plus 1. So we do
Yep.
h of 1 by 4 is equals to 1 over 1 by 4 plus 1.
Yep.
And this is 1 over 1 by 4 plus 1 is 5 by 4. There's one more step to it, which makes it 4 by 5.8.
It's okay. So yeah, 0.8, right?
Yes. Okay. Question number 6. Hmm. 7 is all numbers, exactly like those we just did. And although we did those which were without number substitution, I still wish to try question 6 because these are quadratic forms of each other. Let's try first two of them. F, G, X. So I'm substituting G of X in F of X. 8 minus G of X is X square minus 8. And that's a square. 8 minus A square plus B square minus 2AB. 8 minus X4 minus 64 minus 16x square. Negative X4 and 64, indeed the difference is 56. I'm just taking out that common. And meanwhile, I'm doing the second one. G of X. So substituting the complete f of x in G. A square plus B square minus 2AB x4 minus 16x square A square plus 56. Keeping it that way. When I take negative common, sign of every number would change. Doing it. Minus 56 plus 16x square. Oh, yes. Negative, negative, and this should have been positive. And minus x4. Second one is positive 56 minus 16 and positive 4. Yes. Done. E and B.
Oh, I was watching you do it. I didn't do
Oh,
it myself.
okay. Try one of these. Let's try C part.
Okay. Okay. I did C part.
C, and this is the answer. Top right corner.
Not quite. Okay, I'm just gonna try again. I mean, it's just substituting 8 minus x squared into 8 minus x squared, right?
Yes, but we need to look at A. So we are doing double F. So see f of x 8 minus x square. So when we do f of x, so I'm substituting this complete f of x in f of x. So see, what do I do? 8 minus, that's x. So I don't write x, but I substitute a complete function inside, which is 8 minus x square. See, this f of x is now in place of x. In the previous questions, I've been doing detailed steps which were like this, that we are substituting f of x in f of x. That looks like 8 minus f of x squared first step, and then I replace this f of x again, which is 8 minus x square whole square. Examiner won't mind, you do it either way. So this is 8 minus a square plus b square minus 2ab, and then the negative sign is 8 minus 64 minus x4 plus 16x square. Now rearranging this as 16x square and minus 56 and minus x4. C part, minus 56 plus 16x square minus x4.
Yeah. Okay.
Try D part, that's GG. And this is C of x. GGX is unknown, and G of x is x square minus 8.
Okay.
And this is the answer.
Okay, I'm correct.
Very good. So 7 is just numbers, and let's try just these double offs, C and D. Getting 7 by 34 for the first one, and 1 by 3 What's the second one? I'm going full screen. Let me know if you can still see it.
Okay. Yeah, I can.
I was just encountering some problem. It just loses screen share when I go full screen.
But try moving your mouse.
Yeah, moving it.
Okay, I can see that too. Okay, C is the same. C is correct. And then we're going to do D.
Okay.
D is correct as well.
Very good. Question number 8 is exactly the same nature. I'm skipping it. 9 says, given that f of x equals this, g of x is this, h of x is this, show why it is not possible to evaluate this. So let's start it step by step. Definitely, there will be something where it would be undefined. So f of x is minus x, g of x is x minus 1, and h of x is 1 over x plus 2.
Yeah,
And
for h of x, the denominator is going to be a 0. That's why it
very
would be impossible.
good. So f of 1 is minus 1, and g of minus 1 is minus 2. Very good. So h of minus 2 is 1 over minus 2 plus 2. And that is the statement you'll get. The denominator cannot be 0. Undefined. One more exercise. Complete question 10. The function f of x is given by this. Show that f of x is equal to x. So we just solve f f x. So I'm writing the function with brackets in place of x, and then we substitute the complete function here, that is x plus 1 over x minus 1 and x plus 1 over x minus 1. Let me know when you've noted this. We'll do this together. I'll solve
Yeah, I got
alongside.
it.
Okay, I need to go full screen. Got it? Or still doing?
I'm still doing it.
Okay.
Okay. I think I'm a bit stuck on this one.
Okay, I'll explain. The first step is clear, right? The
Yeah.
substitution part.
Yeah.
So we are done with this first step. And then see, slowly with this, I just took LCM of this upper part above the blue line. Cx minus 1 stays in the denominator, and the numerator x plus 1 is just copied here. And then this x minus 1 goes and multiplies on the other side. Let me write it in more space. I'm writing only the numerator, which was x plus 1 over x minus 1 plus 1. Okay.
Okay.
So the LCM, this is x minus 1. This side stays as it is, and plus 1 is being multiplied with x minus 1. Then we simplify. This is x plus 1 plus x minus 1 minus cancels out. Denominator stays as it is. Numerator is 2x over x minus 1. So after simplification, this is the numerator what we get. And now solving the denominator part. This is the denominator part. That x plus 1 over x minus 1 minus 1. Again, LCM is x minus 1. The first part stays as it is. Minus 1 into x minus 1. Simplifying it, this is x plus 1 minus x plus 1 over x minus 1. So negative positive cancels out. This is now 2 over x minus 1. So 2 over x minus 1 is right there. Now,
And the x minus 1's cancel. And
yeah,
then we have 2x over 2. And then the 2's cancel. And then we have x.
yes. Last part. Although that is the next subsection, inverse function is asking this, let's do it. I'll just quickly do it, and once we go through this, I'll explain the details.
Okay.
We write f of x is equals to y, and f inverse of something gives you something, and that is actually, for example, if I substitute f of 1 is equals to, I get 3. So if I would substitute 3 in inverse, I would get 1 back. So this is the assumption. I'll explain in detail in our next class. So when we write y here, that will give me x. So first of all, first step first, f of x is equals to y. Now I'm copying from the question. F of x is given as x plus 1 over x minus 1 equals to y. And the question examiner is asking me for f inverse x. And that could be done when I make x the subject of the formula. So I'm going for that. So x plus 1 is equals to xy minus y, collecting all the x on one side, taking x as common. 1 minus y is equals to minus 1 minus y. So x is equals to minus 1 minus y over 1 minus y. Now I can replace this x with this f inverse y. So I'm replacing that x with f inverse y is equals to minus 1 minus y over 1 minus y. But the examiner needs to know f inverse x. So we just substitute that variable, and in every place of y, we write x. And that negative sign in the numerator is just irritating. I'm adjusting that to taking out negative common. This is 1 plus x over 1 minus x. I'm taking that negative sign in the denominator. So 1 plus x over x minus 1 is my f inverse x. That's not hard. We'll do it in detail with this subsection.
Okay.
Let me just confirm the time for next class. What is it in the link?
12:15.
Okay. Okay, next concept is inverse function.
Oh, by the way,
Yeah.
I spoke with the person that got like pretty high on the contest at my school.
Yeah.
And yeah, and he was just saying like he like helped me out on some questions and like whatever, but his methods are just to visualize everything and put like variables onto everything. When writing the question out, he draws the question out and then afterwards he labels everything with a variable. And then he tries to make everything really clean, basically. He doesn't want two variables in an equation. And he says instead of doing a lot of questions, work on like your thinking.
Yeah, you're right. Basically, when he just picks out all the summary, he won't have to go back look at the question again.
Yeah. Yeah, and that's basically what he said.
Okay. Okay. We'll see. Inverse function. We dealt with functions. For example, let's say f of x is equals to 2x plus 3. What is basically inverse function? That is, if I just put value of x in a function, it gives me f of x. And in inverse function, I'll substitute y and get x back. For example, we put x and get y, and I'll substitute y and get x. Let's say f of 1 is 2 into 1 plus 3. That's 5. F of 2 is 2 into 2 plus 3. 7. F of 3 is 9. Now, inverse function should give me the values back. How do we find it? We assume, we say let f of x is equals to y. So f inverse of y should give me x. Now, then copying the first statement, this is where our working for inverse starts. F of x is equals to y, and f of x is 2x plus 3 in this case. And in order to find f inverse x, I need to make x the subject. 2x is equals to y minus 3, x is equals to y minus 3 by 2. Now we can see that when x is subject, I can replace it with f inverse y. So f inverse y is equals to y minus 3 by 2. And the examiner wanted to see f inverse x. So I'm substituting x in the bracket and I get x minus 3 by 2. Now just see that we had these values when I was using 1. F of 1 gave me 5, f of 2 gave me 7, and f of 3 gave me 9. Now we're going to check the reverse. I'm substituting 5 in inverse. So f inverse 5 is 5 minus 3 by 2. 5 minus 3 is 2. 2 by 2 is 1. then f inverse of 7 is 7 minus 3 by 2, that's 2. F inverse of 9 is 9 minus 3 by 2 is 3. So this is the relationship between them. If you substitute a in f of x, you get b, and in inverse, you'll substitute b and get a. The other relation between them, graphical relation, is that they are reflection of each other in y is equals to x. This is x-axis, y-axis, and the line y is equal to x. Now let's say this is f of x. So f inverse x will be a reflection in y is equal to x. F inverse x. Okay. Find the inverse of each function. So question number 1, A part. F of x is equals to 7x. First step, y equals to function. Second step is make x the subject. Third, replace f inverse x is equals to x over 7. F inverse x in place of x, I did that directly, and x in place of y, replace that. So x by 7. F of x is equals to 1 over 7x cube. Step 1, y is equals to 1 over 7x cube. Step 2 is make x the subject of the formula. So this is x cube is equals to 1 over 7y. X is equals to cube root 1 over 7y. Step 1 equal to y. Step 2, x made the subject. And step 3 is replace. So f inverse x is equals to cube root of 1 over 7x. C part. F of x is equals to x cube. Step 1 equal to y. Step 2 make x the subject of formula. Step 3 replace f inverse x is equals to cube root x. D part. F of x is equals to 4x plus 3. Step 2 equals to y. Step 1 is equal to y. Step 2 is make x the subject of formula. 4x is equals to y minus 3. X is equals to y minus 3 by 4. And the last step is replace. So we write f inverse x in place of x and x in place of y. So that's the inverse. Try E part. F of x is equals to 1 by 2x plus 5. And step 1 would be equate with y and then make x the subject and finally replace.
Okay, so f of inverse x would equal to 2x plus 10.
That's minus.
Oh, 2x minus 10?
Yes. Most important is just making the subject part. F of x is equals to x plus 2 equals 2 over 2. First step, equal to y, making x the subject, replacing f inverse x is equals to 2x minus 2. Step by step, we'll be having more uh, x at different places. So making subject would be the important part. Try this G part.
F inverse x equals 3y plus 2.
Do that. Y is equals to 3x minus 2. Y by 3 is equals to x minus 2.
Oh, sorry. Y by 3 plus 2.
So f inverse x is x by 3 plus 2.
Yeah.
That is one way of writing, and that's your choice if you want to take the LCM. Both are fine.
In the exam, which would be better? Either?
Either, no issues.
Okay.
Examiner writes this OE. That means or equivalent. Any
Okay.
equivalent. H part f of x is equals to 2x plus 9 by 2. Cross multiplying.
So f of inverse x would be 2x minus 9 over 2.
Yes. And this is interesting. X at two different places. F of x is equals to 2 into x plus 1 by 4 minus x. Are you getting this?
So this is for the answer, right? No.
See the working steps.
Yeah.
First, we equate with y, first step, and then we just cross multiply. So when this goes on the other side, that is 4y minus x, and on left hand side, we open the bracket 2x plus 2. And then we collect all the x on one side. So these were x. So all x on one side, all the other numbers on right side. And then I can take out x as common. Simply divide the other bracket on the other side. And that's it. Replace.
Okay. I see. So we just move it to the other side and multiply it by the y, and then move the x to one side. Okay.
J part. F of x is equals to x cube plus 5. X cube plus 5 equals y. Y minus 5. Cube root of y minus 5. And finally, f inverse x is equals to cube root x minus y. You getting this?
Yeah. Is there another one with two x's?
Yeah, the last one.
Okay.
Let's do that.
Okay, my final answer is f of inverse x is equal to 1 plus x over x minus 1.
Correct. Okay. Question 2 says for each pair of functions, determine whether g of x is an inverse of f of x. There are two ways we can do this because this time we have the answer in front of us. I'm writing the first one for a comparison of two methods. F of x is equals to 2x minus 6 and g of x is equals to x by 2 plus 3. So it says are the inverse of each other. Inverse of f of x is g of x or not. So I'm writing y is equals to 2x minus 6. So y plus 6 is equals to 2x. This is y by 2 plus 3 is equals to x. So f inverse x is equals to x by 2 plus 3. So I can see yes, right? That was one method.
Yeah.
Another method could be f of x is equals to 2x minus x already. And if I just substitute any number into 1 minus x, I'm getting minus 4. Now I'm going to substitute this minus 4 in the other function. G of minus 4 is equals to x by 2 plus 3 g of x. So g of minus 4 is equals to minus 4 by 2 plus 3. That's minus 2 plus 3 and 1. So that's a yes again. Because when I substituted 1, I'm getting minus 4. So when we substitute minus 4, I get 1. Getting the point?
Yeah, it would be a lot easier to just plug in a value and then see.
Yeah. Definitely that would be easy in many cases. So if I just use 1 here, f of, wait, let pencil go. Okay. See, f of 1 is just 12. And in the inverse, g of 12 is 12 by 12, that's 1. So it is a function, yes. Try C part.
No,
Good. Let's know. C part.
no.
I think that's a yes. Let's try 1. That is 1 cube minus 2 is 1 minus 2, that's minus 1. Now we substitute minus 1. I'm having cube root 1 and getting 1.
And cube root can either be positive or negative, so it's correct.
Yeah.
Okay.
And basically that minus 1 was going to be in x, not in the root. Let's try one more value for the same function to clear any doubts. So if I just substitute 2, that is 8 minus 2 is equals to 6. I'm substituting 6 in the other function, so 6 plus 2 is 8 and cube root of 8 is 2. So that's a yes. We substitute 2 to get 6, then we substitute 6 to get 2. So that is a yes. Number 3, given that the function g of x is equals to x by 3 minus 44, then we have to find the inverse. G of x is equals to x by 3 minus 44. So x by 3 minus 44 equals to y. X by 3 equals y plus 44. X is equals to 3y plus 44 into 3, 112, 132. So G inverse of x is 3x plus 132. For each function, find f inverse x and f inverse. Okay. Question number 4. A part is f of x is equals to 5x. 5x is equals to y. X is equals to y over 5. So f inverse x is equals to x over 5. And second part says that we are substituting the inverse in the original function. So there's one more relation. Sorry, we already discussed that y is equal to x. This will turn out to be x. So let's just see that f, and I'm substituting f inverse x in that. So basically that's 5 into x by 5, and I'm getting x. Let's try one more before any conclusion. B part is f of x is equals to x plus 4. X plus 4 is equals to y. X is equals to y minus 4. So f inverse of x is equals to x minus 4. Now I'm substituting the inverse function in the original function. So f inverse x. There goes the original function. Bracket x minus 4 already, plus 4, so getting x. Why are they always equal? Because we just studied the relationship that they are reflection of each other and y is equals to x. So where they will be substituted in each other is basically the point of intersection, and at that point they are equal.
So when f of f inverse x, it would always equal to the f.
X.
It will always equal to x.
Yep.
Okay.
F of x is 2x minus 7. So 2x minus 7 is equals to y. 2x is equals to y plus 7. X is equals to y plus 7 by 2. And f inverse x is equals to x plus 7 by 2. Now we substitute in the original function, which was 2 bracket minus 7. This bracket is x plus 7 over 2. So see, when we multiply this 2 inside, we just cancel that out. X plus 7 minus 7, we are again left with x. Now remember what happened when we were doing this. F of x equal to something. When I substituted x, I got f of x. And in inverse, you get that back. Basically, we substituted x and we got y in function. And in inverse, when we substituted y, we get x back. So what is actually happening? Whatever you substitute in the function, in this case, that is basically you've substituted x and you got this. And when you will put this in inverse, it's getting you back, right? We substituted
Yeah.
x and we got y. And when we put this in inverse, we get x back. That is why we are getting x in every of these questions. We substituted x, we got something. We put that exact back in inverse, so we get back x. You substitute a in the function to get b. And then you put b in inverse, will get you a back. That is why we are getting x back, because we were substituting x in the original function. The original function itself is a substitution of x. Question 4D. F of x is equals to x cube plus 2. X cube plus 2 is equals to y. X cube is equals to y minus 2. Is cube root y minus 2.
Wait, sorry.
and f inverse x.
Can you explain the thing about like the it equaling to x? Because I don't think I understand it.
Yeah, yeah. I'll explain again. See, what did I substitute? I
X?
substituted x, right?
Yeah.
And when I substitute x, what do I get? I get this,
Yes.
or say I get this. When we
So when we
substitute
sub,
x, I get this. So I'm substituting that thing back in the function. So I'm getting the reverse of it.
so you'll be getting x.
Yes. Because when you substitute x, I'm getting x cube plus 2. So either I put x cube plus 2 in the inverse function, I'll get x back, or I put this in the function, so I'll get x back. They are reverse of each other.
So if you put x cubed plus 2 into the function, then you'll get cube root x minus 2. And if you put cube
Yes.
root x minus 2 into f of x, then you'll get x.
Yes, see this, right?
Yeah.
And when we will open this, we'll get rid of 2, and then cube root will make it x. So substituting x gives you this, and substituting this in inverse gives you x back, and vice versa. So basically, when we were substituting x, I'm getting that inverse. And the most important thing is when we are substituting the inverse function back in function, that means we are equating them and they are equal on this line, y is equal to x. So I substituted x, so I ended up with x. For example, we substitute 7. So 7 into 7 into 7 is 342 minus 2 is 341. So when you put that back, you will get 7 again.
So if you put the result of an inverse function into a function, then you'll get x.
Yes. See, when I put like this was x and this was f of x. So when I substitute a and I get b. So this is f inverse x and this is something. So what will happen when I will substitute b here, I'll get a back. Do you agree with this a and b thing?
Okay.
Only ignore all the other, only this encircled in red. We substitute a, we get b. And in inverse, we substitute b, we get a. The very first thing we did today, um, this one. We assumed a function, this thing. I substitute 1, I get 5. We substitute 2, we get 7. We substitute 3, we get 9. Then we found f inverse, which was y minus 3 by 2 or x minus 3 by 2. So this value at top. 1 gives you 5, 2 gives you 7, 3 gives you 9, and then reverse. When you put 5, you get 1. With 7, you get 2. With 9, you get 3. You're getting that back. So basically, there was x and there was a function. So if I substitute a and get b, and then there was an inverse function, then you got something. So if you substitute b here, what do you get?
A.
A. Now just compare. Substituting a in place of x is giving you b in place of y, right? So
So
when,
substituting A would give us B.
yes, substituting b in place of x is giving you a, and a corresponded to x.
Okay.
A gives you b, Or let's make it like, might be a weird example. For example, if I pay you $2 and you give me a pencil box. So what if I give you a pencil box?
Then I'll pay you 2.
Yeah, that's what's happening. We substituted a in x, but we never substituted a in inverse function. We substituted a in x, got b, and we substituted b in inverse, so we got a back. And a corresponded to x. Now, what are we doing in this current question? We are not substituting 1, 2, 3, 4, 5, 6, 7. We are substituting x, and we're getting y, and this is y. And then when you put that y back, you get x back.
So substitute the x, and f of x you get y. And
Yeah,
then f inverse of x, you put y, then you get x.
back.
Okay.
E part. We'll do this slowly. F of x is 2x minus 1. Now, while we are making the subject, we are not replacing it with any number, but we are actually replacing it with x. Square root of 2x minus 1 equals to y. See, what is substituted? X is substituted.
Yeah.
So squaring both sides, 2x minus 1 equals y square. 2x is equals to y square plus 1. X is equals to y square plus 1 by 2. Now see, we are actually substituting this value back here. See, you substituted x, that is 1, so you got 2. Now you're putting that back in 2, so you'll get x1, 1 back.
We're putting x.
Yeah, for example, let's compare this. If I just substitute, let's say, I'm trying to get no decimal numbers and other one 1. Let me just think. If I substitute 5, that would be 2, 5 times 10. 10 minus 1 is 9 and square root 9 is 3, right?
Mm-hmm.
So that's f of x. Now see, if we work on inverse function, you substitute 3, you will get 5.
Okay.
So that was x substituted in original, and we got this.
So that's your
And
y.
yeah, working our way down, this was inverse. That is why it is
Then,
giving you back the original number. We
and then how do
substitute,
we substitute that back into x?
we're replacing that back. That is why we're getting x back each time. Like, see this 5, we replaced this 5 in original function and got 3.
So if we put
So we
3,
actually replaced
yeah,
3 in this function,
then we'll get 5.
5, and this actual function is going back there. So basically, we are replacing 5 there.
Okay, so for e,
See closely,
if
see
we
closely,
were,
please.
yeah,
When we substitute this 3 in this function, what do we get? 3 square is 9.
9.
9 plus 1 is
Yeah,
10.
10 divided by 2, so 5.
There. And see, I was substituting this 5 and getting that 3. So when we substitute 5 back, we get that 3 back.
Okay, so it's just substitute. Okay, I see. So so if f of x is 1, then that, let's say, hypothetically gives us 2. And then if we substitute the 2 into
That is
the,
actually giving us one. When we talk about numbers, we won't make any guesses. We will talk about exact answers, okay?
oh no, I'm just saying, just like for,
Yeah, I understand how you said hypothetically, but just to avoid any sort of
okay,
confusion, because we can have actual answers, right?
mm-hmm.
So if And just avoid 1 because substituting 1 is giving you 1. So to avoid that confusion, see f of 5 is giving me
9.
2 into 5 minus 1. 2 5 times
That
10
would be
minus 9
3.
squared. That is 3. So may I just say that x is equals to 5 gave me y is equals to 3.
Yeah.
And without solving, I would say that f inverse of 3 will give me 5.
Okay.
Now may I say I substituted x and got y, and when I will plug in y back, I will get my x back.
Yeah.
Now let's use this work formula. This was f inverse of x is equals to x square plus 1 by 2, right?
Mm-hmm.
Now what are we actually doing? We are putting this thing back in this x.
So we're substituting.
When you substituted x,
Yeah.
5, we get y3.
Yeah. So now we're
So
substituting the 3
yes,
into the x, and then we're
yes.
getting 5.
So yes, that is going to make it 5, and that was actually already 5. See, this 3 goes back here
Mm-hmm.
because that's what we are getting. That is what my value is. So I'm putting that value back. So that is 3 square 9, 9 plus 1, 10, 10 by 2 is 5. So I am putting that 5 back. So obviously I'll get that. Uh, what did I just do? Yeah, get my x back.
Okay.
2 5 is 10 minus 1 square root 3. When I'm substituting this back, and this was x. So I'm getting that back.
Okay.
F part says that f of x is equals to 9 over x. 9 over x is equals to y. We need to make x the subject. 9 over y is equals to x. So f inverse of x is 9 over x. Why did it change? Did I make any mistake? Y is equals to this? No. So if I just substitute f inverse x, that is 9 over f inverse x, and f inverse x is 9 over 9 by x. That is 9 into x by 9. Leaves me with x again.
Um. Okay. So we put the 9 over x into
Into the x of original function.
the x original, and then we just cancel. Okay.
This was the function 9 over x. So we substituted inverse in place of x.
So we first did the inverse, and then we did the f, and then we put the f
Yes.
into the inverse, right?
Inverse into the f. We read it right to left. We
Oh, okay.
substitute
Yeah.
inverse in f.
Okay.
Try g part.
I don't think I'm getting I'm doing the right thing. Because my answer is not matching
It's
up.
not. Okay, this is x cube minus 1. This is equal to y. Now we make that subject. Now cube root both sides. This is f inverse x is equals to, that was y. Now this is f inverse. Now f inverse x would actually be f inverse x cube minus 1. Right? Now I'm bringing that value in, which is cube root
So the
x
cubes
plus 1.
cancel.
Yes.
X plus 1 minus 1. What? So wait, which part was this again? It was
G part.
G part. Oh, I was trying to do D. Okay. But
Do you want me
still,
to do that again? D part?
yeah. Because still, why I don't know why I got it wrong.
Maybe you mixed two values. D part is f of x is equals to x cube plus 2.
Mm-hmm.
X cube plus 2 equals to y. X cube is equals to y minus 2. X is equals to cube root y minus 2. And there is my inverse, f inverse x equal to cube root of x minus 2. I'm going to plug this in
Yeah, it
back
should
here.
work. Yeah, because the 2's would cancel. I think I just like, I don't know, maybe I saw them as one question because they were on top of each other.
Yeah, maybe
But,
you just mix the values.
okay.
The cube goes away. That's x minus 2 plus 2. Cancels out and
Yeah.
you're left with. So try number 5. Given that the function h of x is equals to this, for each value find this. So number 5 says h of x is equals to 2 into x minus 3. First thing he wants us h inverse 10. 2x minus 6 is equals to y. X is equals to y plus 6 by 2. H inverse of x is equals to x plus 6 by 2. And H inverse 10 gives me 10 plus 6 by 2. That's 8. Now, what we've been doing in question 4, without solving, this should be 20. Now, let's try that. It says H inverse, right? B
Yeah.
part is H inverse 20. So H inverse 20 only would give me 20 plus 6 by 2 is 13. This is what I've used for H inverse. Now I'm going to put back this 13 in H. 13
That's
minus 3 is 10, and 10 into 2 is 20.
yeah.
See, this comes back. Same way. No, not same way. That's H inverse. H inverse.
H inverse. So we just plug whatever we get back into the H inverse.
Yes. H inverse of 26 is 26 plus 6 by 2. 26 plus 6 is 32 by 2 is 16. So H inverse 16 again is 16 plus 6 by 2. That's 22 by 2 is 11. This H inverse 26 is 16. Then we plug in this 16 in H inverse again.
Wait, it's 16. Okay,
Yes.
yes, it's 16. And then we put the 16 back in and then we get 11. So our final answer is 11, right?
Yes.
Okay.
Try question number 6. What did you get in A part?
A part, I got 5.
That's not my.
Wait, no, f of x e has to equal to 0.
Yes.
Oh, okay. So I have to make 1/2 x plus 5 equal to 0. Okay. So -10? Yeah.
Yes.
I'm right now on C part.
Okay. Solve this equal to this, correct to 2 decimal places.
So x equals 1.54.
How you're talking about C part?
Yeah.
Check it. 1 by 2x plus 5 is equals to 4x minus 2 by 5. So we just rearrange. Five plus 2 by 5 is 27 by 5. And that's 7 by 2. So 27 into 2 by 5 into 7. 54 by 35. And up to 2 decimal places, this is 1.54.
Yep.
D part.
-56.4.
Yep.
Okay. So for I got 3. And then for I, yeah, negative 7.8.
That was chapter